Today, we're going to dive into the work of one of the 20th century's most incredible thinkers, R. Buckminster Fuller. We're looking at his masterwork, Synergetics, what he called the geometry of thinking. And get this, he designed it to be nothing less than an actual operating manual for the universe.
So let's just start with a really fundamental question, one that Fuller himself would ask. What is the simplest possible thing, the most basic building block that can actually exist in our reality?
Now, if you're like me, your brain probably zaps right back to high school geometry class. And you'd say, well, a point, right? A point has 0 dimensions. Or maybe a line, which only has 1. That's what we were all taught. But for Buckminster Fuller, this wasn't just a simple mistake. No, it was a fatal flaw. He argued that things like points and lines, they're just pure abstractions. You can't actually find one in nature. Physics has never pointed to a dimensionless point or a perfectly straight line. So by starting our thinking with things that don't physically exist, Fuller said we were building our entire model of reality on a foundation of sand.
Okay, so here's our roadmap. We're going to explore Fuller's totally new geometry, unpack the principle of synergy, find the universe's absolute minimum system, uncover what he called nature's coordinate system, and then, finally, think about our own cosmic function in all of this.
All right, first up, a new geometry of thinking. Or, as Bucky might have put it, how to operate universe. Fuller was really driven by this powerful conviction. He said, I have found that universe is actually operating in an entirely different way from the way society thinks it is. So Synergetics was his, incredibly ambitious attempt to map out that real operation. So what's the big shift here? Well, conventional geometry, it starts with abstract little parts, those points and lines, and it builds up from there. It's based on axioms, which are really just things we assume are true without proof. Synergetics completely flips this on its head. It starts with the whole, the entire observable universe, the only thing we can actually experience. And then it figures out the parts by dividing that whole. It's a system based not on assumption, but on real experience. And this brings us to his number 1 non-negotiable rule: always proceed from the macro to the micro. You have to start with the biggest possible picture, the universe itself, and only then can you work your way down to the detail. Okay, on to section 2, the principle of synergy. This is really the cornerstone of his entire philosophy. It's the idea that the whole is always more than the sum of its parts. So what even is synergy? It's the behavior you see in whole systems that you could never have predicted just by looking at their parts all by themselves. It's that unpredictable magic that happens when things start working together. Fuller's favorite example of this was metal alloys. Okay, so you take some chrome, you take some nickel, and you take some steel. You can study each of them on their own, their strength, their melting points, whatever. But when you combine them, you create an alloy whose incredible heat resistance is completely unpredictable from any of those parts alone. That's synergy. The performance of the whole is way, way greater than what you'd expect from its parts. And this leads to a kind of synergetic math, which explains the 4 you're looking at. In normal math class, 1 + 1 is 2, simple. But in Fuller's geometry, when you bring 2 triangles together, you can actually create a tetrahedron, a shape that has 4 faces. See, the 2 new faces just emerge out of the relationship between the parts. In this universe, 1 + 1 can equal 4. Now that's synergy. Okay, section 3, the universe's minimum system. So if a point or a line isn't the simplest thing, then what is? Let's follow Fuller's logic as he hunts for the simplest possible something.
And the logic he uses here is just beautifully simple. A single point, it can't divide space. It has no inside or outside. 2 points making a line, same deal. 3 points making a triangle, still nothing. None of them create an inside versus an outside. But the moment you add a 4th point that isn't on the same flat plane, boom, you've created the very first possible division of the universe into a definite inside and a definite outside.
And that system is the tetrahedron. For Fuller, the tetrahedron is the fundamental quantum of reality. It's the simplest possible container, the absolute minimum shape you need to create a difference between here and, everywhere else. And here's where he makes this incredible leap. This isn't just about physical shapes. Fuller argued that an idea, any idea, needs a boundary to even exist. You have to define what it is versus what it is not. And so he said that thought itself must have a minimum structure. Conceptuality is tetrahedral. Just to have an idea in the first place is to form this minimum system in your mind. All right, section 4, nature's coordinate system. So now that we have the basic unit, let's look at the dynamic framework it all operates in, these invisible structures of reality. Fuller proposed that underneath everything, all the energy, all the events in the universe, there's a universal framework he called the vector equilibrium. He saw this as nature's own coordinate system, something way more fundamental than the artificial XYZ grid we use. So what is this thing? Fuller called it the zero phase of energy. Try to imagine a state of just perfect, absolute balance, totally motionless, sizeless, timeless. He said it's a condition that nature is always pulsating through, but it never actually rests in. It's the pure metaphysical potential from which all the unbalanced, messy, physical reality that we actually see emerges. And this framework gives rise to another one of his huge ideas, tensegrity. He actually coined the word himself. You can see it right in there. It's a mashup of tensional and integrity. It's this wild structural idea where solid, compressed parts, or struts, just kind of float inside a continuous web of tension. Think about a normal brick wall. How does it work? Continuous compression, right? Every brick is just pushing down on the one below it. It's heavy, it's rigid. A tensegrity structure completely flips that script. It uses these isolated islands of compression that are held together by a continuous network of tension. And the result? You get structures that are just unbelievably lightweight, resilient, and strong. And the power here is immense. Tensegrity replaces bulky, solid mass with elegant geometry. You get these incredible strength-to-weight ratios. Any force that hits it is distributed instantly across the entire system. And this isn't just some clever engineering trick. Fuller saw this as nature's fundamental way of building everything, from atoms and viruses all the way up to galaxies. All right, final section. Let's zoom all the way back out from these tiny structures to the big, macro view and ask, what is humanity's role in this whole grand, interconnected universe? Fuller's answer was pretty profound. He wrote, humans are metaphysical. You and I are awareness, the identity of the weightless life. So in his view, we aren't just our physical bodies. We are the universe's awareness. We're the part of the system that can actually understand itself. So our cosmic function then is to use our minds to discover these timeless, universal principles, like synergy and tensegrity. Our job is to apply them to solve problems, to consciously help the universe regenerate itself by learning to do, as he famously put it, more with less. So at the end of the day, Synergetics is really asking us to see the world differently, not as a collection of static, separate things, but as a dynamic geometry of relationships. And that leaves us with one final question for you. What bigger patterns in your own world have you been missing just because you were only looking at the parts?